Okay, question number 1. So d squared plus a squared into y is equal to tan ax by the method of variation of parameters. If you want to solve a differential equation using the method of variation of parameters, you are supposed to find the complementary function first. If you want to find the complementary function, you're supposed to write the auxiliary function, solve the auxiliary function, you write the complementary function based on the nature of the roots of the what? Of the auxiliary equation. M squared plus a squared is equal to 0 is the auxiliary equation. M squared is equal to negative a squared. M is equal to plus or negative ai. The roots are complex roots. Okay, so now the complementary function is equal to e to the power alpha x c1 cos beta x plus c2 sine beta x. This is equal to alpha in this case is equal to 0 x c1 cos beta is equal to a plus c2 sine a x. This is equal to c1 cos a x plus c2 sine a x. This is the complementary function. Remember, I said that the complementary function, if you are using the method of variation of parameters, is given in the form c1 f1 plus c2 f2. Okay, it means that f1 is equal to cos a x. Okay, f2 is equal to sine a x. This is f1 and this is f2. The first derivative of f1 with respect to x is equal to, this is equal to negative a sine ax. The first derivative of f2 with respect to x is equal to, this is equal to a cos a x. We have f1, we have f2, first derivative of f1, first derivative of f2. Now we can find the Wronskian's determinant w. Now w is equal to f1 f2 like this. So this is equal to the determinant of cos x sine a x, negative a sine a x a cos a x. This is equal to, if you want to find the determinant this by this, this is a cos squared a x plus, it's negative a sine squared a x, so it becomes plus a sine squared a x. Factor out a, you remain with cos squared ax plus sine squared ax. We know that sine squared ax plus cos squared ax is equal to 1. Okay, so the Wronskian's determinant is equal to a. W is equal to a. Now you are supposed to find the value of p. Remember, p is equal to negative the integral of f2 into r divided by w with respect to x. This is equal to negative the integral of f2 is sine a x into r is tan a x. This is r divided by a. This one. Factor out 1 by a. This is negative 1 by a integral of sine ax tan ax dx. This is equal to negative 1 by a sine ax into tan ax is equal to sine ax by cos ax with respect to x. This is negative 1 by a. This by this is sine ax into sine ax with sine squared a x over cos ax into dx. This is negative 1 by a into sine squared ax is 1 minus cos squared ax divided by cos ax dx. This is equal to negative 1 by a 1 by cos ax minus cos squared ax by cos ax into dx. Okay, this is equal to negative 1 by a, the integral of 1 by cos ax. This is nothing but sec ax minus cos ax respect to x. Okay, so we have to integrate. We want to integrate sec x minus cos ax respect to x. This is equal to negative 1 by a. If you integrate sec x, the answer is 1 by a log sec ax plus tan ax. Okay, minus. Now we have to integrate this. If you integrate this, we want to integrate cos ax. The answer is sin ax by a. Okay. Factor out 1 by a. This becomes, factor out negative 1 by a. This becomes 1 by a squared into sin ax minus log sec ax plus tan ax. So this is the value of p. Let's find q. Remember, q is equal to the integral of f1 into r by w with respect to x. This is the integral of f1 is cos ax, r is tan ax divided by a dx. Factor out 1 over a. This is cos ax tan ax. This is equal to 1 by a. This is cos ax into sin ax over cos ax. Okay, cancel this. So this is 1 by a, the integral of sin ax with respect to this. This is 1 by a. And then we have to integrate sin ax. You get negative cos ax by a. Okay. final answer of the value of Q is negative cos AX over A squared. This is Q. P, the particular integral Pi is given by Pf1 plus Qf2. You substitute P1, we have P1, okay. F1, I still remember the value, I still remember F1. F1 is cos AX, okay, plus Q. F2 is sin AX. Then you write the solution. This is equal to CF plus PI. Okay.